let's use the completing the square method to find the value of x in an area type problem. Now, those of you that already know the quadratic formula will recognize that once we get this equation set up, we could use the quadratic formula to solve it, which is totally fine to do. I just want to show another example of completing the square. So here's what we have. We have a parallelogram, and we'll recall from geometry that our formula to find the area of a parallelogram is base times height. And base and height need to be perpendicular. So let's plug in some values that we know and go from there. So our area was given to us, that's 48. Our base of the parallelogram is x plus 6, and our height is x, so those are what need to be multiplied together. So let's go ahead and distribute to simplify this. So I get 48 is equal to x squared plus 6x. Now, I could try to factor this. This one turns out to be unfactorable, but if I subtracted 48 to make it equal to 0, I could try to factor it. Also, at this point, if I wanted to use quadratic formula, I'd subtract the 48 to also make it equal to 0, and then proceed with that. But let's go ahead and use completing the square method. So I need to find my magic number. Recall that the magic number is our b value, the coefficient of x. Let's take half of that and square it. So half of 6 is 3. And 3 squared gets us 9. So what I'm going to do is add 9 to both sides of this equation. So I'm going to rewrite this as x squared plus 6x plus 9. And because I want to keep this balanced, I want to also do 48 plus 9. I need to add the same thing to both sides. Simplifying then gets me 57 over here. The reason that we called that the magic number is x squared plus 6x plus 9 now factors. Two numbers that multiply to 9 and add to 6 are 3 and 3. So I would write x plus 3 times x plus 3, or x plus 3 squared. That's why I get this name. That's where the name comes from, to complete the square. So to finish this then, let's take the square root of both sides. Square root of 57, I'm just going to put down plus or minus square root of 57 for now. 57 is prime, I believe, so that will not factor. Or is it prime? Maybe it will factor. Turns out it doesn't matter. We're going to just get a decimal anyway. Squaring a square root, those will cancel out, so I'm left with x plus 3. To finish this problem now, I need to subtract the 3. So I'm going to switch around the order of some things a little bit. But moving that 3 to the other side will make it a negative 3, and then plus or minus the square root of 57. Now that's the exact answer, and those are the two answers if I just wanted an algebraic problem. But in this case, x represents a real-life value, so both of our answers may not both make sense. What I'm going to do is use a calculator to just get a decimal approximation of this number. So I'm going to do negative 3 plus the square root of 57. Oops. Negative 3 plus the square root of 57. And then I'm going to figure out what negative 3 minus the square root of 57 is. So using a calculator, I find those values to be approximately, let's see, I want to make sure I do the right one. Negative 3 plus the square root of 57 is approximately equal to about 4.55. And negative 3 minus the square root of 57 is approximately equal to, oops, I didn't write it down in my notes, but I know it's going to be something negative. And so what that's going to tell me is I can't use that value. I can't have a negative answer because x represents the side of a parallelogram, or the height of a parallelogram. So in this case, 4.55, or negative 3 plus the square root of 57 is my only value. Also, I'm going to include a label with that. Since this is a distance, I'm going to put meters with that label. So that's the answer I'll give. Again, sorry about that. I thought I had it down in my notes, but I did not write it down. But I do know that would be negative, and I cannot have a negative value. So there is my only answer that I will get.